Hello everyone, welcome to my fourth lecture of signals and systems. So today we will discuss about discrete time complex exponential and sinusoidal signals. So in case of discrete time signal, we use third bracket instead of first bracket like we used in continuous time signal, and x of n is equal to c into a to the power n. Okay, instead we use in continuous time signal c into e to the power at, but c and a are complex. Okay, so it can be expressed as x of n equal to c into e to the power b into n, where a is equal to e to the power b. So here are four examples for different values of b. Okay, for which equation? For discrete time equation, that is x of n equal to c into e to the power b into n. When b is greater than 1, the output of the signal will be, that is x of n will be left top one. Okay, the picture on the left side of this slide. Okay, and when the value of b is greater than 1, we get the right one picture, and when the value of b is within 0 and -1, we get picture like on the bottom portion of the left side of the picture, and the right side picture is when b is less than -1. Okay, so previous pictures also are for values of c and a when they are real, but when they are imaginary, okay, we get pictures like this. These are different values of b, like for cos 2 pi n by 12, the output will be like on the left side of the picture. The middle one is cos n by 6 and the right one is cos 8 pi n by 31. Okay, so in the previous case the value of b was real and c was real as well, but in this case b is imaginary. Okay, and when the b is imaginary, we get a sinusoidal signal. Okay, and when the value of alpha, that is b, is complex, okay, when the value of b is complex, so we get decreasing or increasing sinusoidal signal, like the left one or the right one. For left one, the value of alpha is, the magnitude of alpha is less than 1 and the magnitude of alpha is greater than 1. Okay, for the right one, and the equation that we are using to plot this output graph is mentioned below. Okay, so now we'll talk about linear time systems and non-linear time system. Okay, linear system and non-linear system. So linear systems are those which follow the law of superposition, and non-linear systems are those which do not follow them. So what is superposition? The law of superposition. So law of superposition comprises of two laws: the law of additivity and law of homogeneity. So what is additivity? So we'll see that in the next slide. Okay, but both conditions must be satisfied for the system to follow the law of superposition. That means if a system is following the law of additivity as well as the law of homogeneity, then only we'll call it superposition. If the system is following only additivity or only homogeneity, we cannot call it a system which is following the law of superposition, that is, it is a linear system. Okay, so if any one does not satisfy, the system is non-linear. So what is additivity? So if a and b input creates output x and y for a system, then a plus b must produce as output x plus y. If this is true, then the system is additive system and it is following the law of additivity. So here we can see the picture in the block diagram. The input is a, which is producing output x, and input is b, which is producing output y. And for an system which is following the law of additivity, the summation a plus b input summation would create the summation of the output, that is x plus y. For example, here we have a system y is equal to x square. So is the system additive or non-additive? Okay, so let's find out. So x is, suppose x, the value of x is x1, so y is equal to x1 square. Now suppose another value of x is x2, so y2 is x2 square. So if we input the summation of these two values, that is x1 plus x2, then for a system to be additive, the output of the signal must be similar to x1 square plus x2 square, because those are the outputs. Okay, so first we do the summation of the inputs and put it in the system, and what is the output? The output is x1 square plus 2x1 x2 plus x2 square. And what is the output? What is the summation of the output? It is y1 plus y2, which is x1 square plus x squares. So it is not, they are not similar, they are not equal. So this is not additive system, this is a non-additive system. Okay, it is a non-linear system. Why we are saying that it is non-linear, though we have just found that it is non-additive, but we have not yet found out whether it is homogeneous or non-homogeneous system. Because if one of those properties does not satisfy, we can 100% surety, with 100% surety we can say that the system is non-linear, because for the system to be linear, the system has to satisfy both the conditions. So what is homogeneity? So if a input creates output x, and then for a system to be homogeneous, the k is a constant. Okay, so ka must produce output kx. So suppose here is a system, when we are giving input a, it is producing x output, then for the system to be homogeneous, the ka must produce kx output. Okay, so is the below system homogeneous or non-homogeneous? Y is equal to x square, the same system. So let's find out. So x equal to x1, so y1 is equal to x1 square. So we multiply x1 with a coefficient, or you can say a constant. So y1 is equal to a into x1 whole square. Okay, which results in a square into x1 square. So in this case, a is any constant value, can be 2, can be 4, can be 3, can be 9.11, any value. Okay, and when you multiply the output with the same constant, that is a, the output is a into x1 square. So for the system to be homogeneous, it should have been the a x1 square and a square x1 square should have been equal, but they are not, they are different. Okay, so this is not a homogeneous system. Alright, y is equal to x square, not a homogeneous system. So that's it for today, guys. Thank you very much.